Hi everyone, in today's lesson we're going to review logs. First, let's review the definition. Well, a logarithmic function is the inverse of an exponential function. So this word inverse means that we will switch the x and y values. Or an inverse by definition truly means a reflection over the over the line y equals x. So by doing the reflection over the line y equals x, you're actually switching the x and y values. So all exponential functions are in the form y equals b to the x. So therefore, the inverse or the log function would be x equals b to the y, right? We switch the x and the y values. So that is what the inverse would be, or the log, right? So what am I talking about? Let's look at this in forms of a picture. So this blue graph right here is an exponential graph, exponential growth to be specific, y equals 2 to the x. Now here's the line y equals x. If we do a reflection over this line, we get our logarithmic function. Our logarithmic function will be in the form x equals 2 to the y, right? If this is y equals, we switch the x and the y. So the x becomes y, the y becomes x. And we actually can convert this exponential to a logarithmic form. This form we'll talk about later on. Just wanted to give you an idea of what a logarithmic function is. So we have common logs and natural logs. So common logs are logarithmics with a base of 10. So when the base is not indicated, the base 10 is implied. So I could write just basic log of x. And what that means is log base 10 of x. So that's the definition of a common log, okay? And here's the graph of what a common log looks like. Looks very similar to this graph up here in red. A natural log is a logarithmic with base of e, and those are called natural logs. And they're denoted by ln, not in, ln. So ln of x is your natural log, and what that means is log base e of x. Okay, so when you see ln, think log base e. And when you see log of x with no base written, think log base 10. So here is your exponential function of e to the x. Here is your inverse line, and here is its reflection. So this would be your graph y equals ln of x. All right, so that's just a couple of definitions that you should need. Now let's move on to the back. So we can convert between logs and exponentials, just like I showed you before with the x equals 2 to the y and y equals log base 2 of x. They mean the same thing, right? So let's talk about how they make sense. So I like to call this the loop-de-loop method. So, whoops, sorry about that. I will call this, like I said, the loop-de-loop. So let's just say I have log base b of a equals c. What that can do, I can change from the loop. I'll start at the base, jump up to the exponent, come back down to the answer. So this means to go up to the exponent, and this means to come back down to the answer. So what am I doing? I'm going to say that this is equivalent to start at the base, b to the c power equals a. So b to the c equals a. So does this make sense? Does 2 to the y, it's okay that the arrow is going the other way, it's just because the equal sign is that way. So does 2 to the y equal x? Well, yeah, we start at the base and we circle it. So 2 to the y equals x. And look, that's the same thing here. So loop-de-loop. I'm going to do the first example with you. So I want to take this log and change it into exponential form. So I start at the base, go up to the exponent, come back down to the answer. So this would be 9 squared equals 81. All right. Now this one, I want you to go from exponential form to log form. But now I'm realizing these are log forms, so I'm sorry that that's a typo. So we actually have to put ln of e equals 1 here, and log of x squared equals 4 here. And then we're going to change them to exponential form. So the first thing you may want to remember is that ln of e is the same thing as saying log base e. So log base e of e equals 1. So we're going to circle, start at the base, jump up to the exponent, and come back down to the answer. So e to the first equals e. Now this third one, or we need to know that since there's no base written, it's a base of 10. Circle the base, jump up to the exponent, come back down for the answer. So 10 to the fourth equals x squared. We'll practice more of that in class, but that's the idea from going from log to exponential form. All right, the last thing I want to talk about are these log properties. So we have a condensed log form and expanded log form. Product rule means to multiply, quotient rule means to divide, and power rule means to raise a power. So the condensed form of the product rule is log base b of a times c. What that looks like in expanded form is log base b, make sure you write it smaller, log base b of a plus log base b of c. Notice the exponent rule. If I'm multiplying, I add the powers. All right. Quotient rule would be log base b of a over c is your division. What is the rule when I divide exponents? I am going to subtract. So my expanded log form is log base b of a minus log base b of c. Your power rule is log base b of a to the c power. What's the rule when I raise a power to a power? I multiply. This one I like to call drop it like it's hot. What we do is we multiply the power in front by dropping it. So c comes in front, drop it like it's hot, multiply log base b of a. So those are your three main log properties. So in this first one, I've given you condensed log form. Notice I've got a couple of rules here. I'm multiplying a squared and b to the third together, right? There's a multiplication in between these, but I've got some powers there as well. So let's first expand it using the multiplication. So we're going to use our first rule here. So this will be log of a squared plus log of b squared, no, b to the third, excuse me. But now that we have powers, we have to take it one more step, drop it like it's hot, and bring them in front. So 2 log of A plus 3 log of B would be your final answer. All right, so now let's take a look at this one. I'm in expanded log form. I want to go back to condensed. Condensed, notice, is usually one single log. So we're going to condense this to log of some expression. So the subtraction means that we came from division. So we have to go back to division. And if this 5 is hanging out in front here, that means it was dropped. Drop it like it's hot came from this power. This 4 was dropped like it was hot, so it's that power. So that would be a to the 5th over b to the 4th. All right. The last one, we have to know that the square root of b is actually b to the 1/2. We learned that the other day, right? So log of a b to the 1/2 divided by c. So now we've got a couple of things. We've got multiplication on top and then division on the bottom. So we're going to have a plus and a minus. So let's try to do this in one step. Don't forget this power needs to be dropped like it's hot. So we've got log of a plus log of b to the 1/2. But technically, since we have that power, we could just throw it in front. So 1/2 log of b. And then now we are subtracting because we have division. So we're going to subtract log of c. So that would be your expanded form. Could you have done the preliminary step here and then dropped it? Absolutely. But that's just your final answer. All right, I know I did a lot. We're going to go over it again tomorrow in class. So if you have any questions, now is a good time to jot them down. And I will see you tomorrow in class. Have a good night.